Okay, let's start with humanoid robots. Here on this image you see, well, one logogram and two humanoid robots. And the big question is, what the hell are humanoid robots? Well, here is an overview. We have, on the top left, we have a humanoid robot versus a non-humanoid robot. And humanoid robots are machines that share some features with humans, but which are clearly identifiable as non-human. So this robot has arms, has a face, doesn't have legs. But apart from that, there are some human features, so we can call him a humanoid robot. Non-humanoid robots are, for example, drones, as you can see here. That's typically, and it's a big question, is a coffee machine a non-humanoid robot? Well, the coffee machine can carry out tasks independently, but the tasks are too limited. That's why we wouldn't say it's a non-humanoid robot. It cannot act independently. So it's a machine that can act in a way independently and has human features. That's a humanoid robot. Here you see an android. Android are human-like robots. Ideally, and most frighteningly, they have skin and hair. You may have heard about Sophia, produced in Hong Kong. Sophia is a humanoid, is an android. And we have a somewhat scary feeling, don't we? At the moment, this may change. And my bid for cooperation with Hong Kong, by the way, wants to involve one of these questions, namely, are there cultural differences between Europeans and people from Asia in their acceptance of humanoid robots, androids? Some people even have geminoids. A geminoid is a clone, a machine clone of a human. The most well-known one is Professor Ishiguro from Japan. He produced a clone of himself with hair, with skin, with everything. Frightening, isn't it? Well, this is one example. There's also a Danish professor who's done the same thing. They have geminoids controlled from their office. So the idea of the Danish colleague is that he controls the robot from his office. The robot stands in the lecture hall, and while the robot is doing something, he can do different things at his desk. Okay, I don't like the idea very much. Well, these are the humanoid robots, and you may have seen some of them. They all have human features. Some of them look funny. Some of them, well, they are relatively acceptable. And our students, when we asked them before we started with robots, what sort of robots would you prefer? The answer was, by means of an overwhelming majority, humanoid robots, and not androids, let alone geminoids. Okay, so that's first of all the first question. Now the second question is, what should a humanoid robot look like in order to be involved in education? Well, here are some of them. Now look at their size. 1 meter, this is the scale. They're all relatively small, aren't they? Could you imagine such a robot standing here and addressing the audience and talk about economy? I couldn't really. They're too small. Perhaps this one is the Now robot, you see, is about 60 centimeters tall. That could be used, but they're perhaps too small to be taken seriously. We don't take them serious. If they have no authority, they're too small. What about these? This is the scale, 1 meter. We have Poppy, okay. These are 1 meter and 20 centimeters. This one from Iran, Surina 3. Iran, I don't want to say anything about Iran, but I think this is too tall. And this frightens humans. So it's basically these two here. Tall enough to be taken seriously, but small enough to be inferior to us. We humans want to be under control. This one is 120 centimeters tall.
My name is Pepper. Nice to meet you.
Okay, so that is Pepper. Can you hear him well?
Yeah.
Okay, and Pepper is this robot here, 120 centimeters. He is never taller than you, even when you sit. Then it's the same height. And so he is ideal for becoming an educational partner. So that's the first thing. Now we know what a humanoid robot should look like in education. And SoftBank Robotics, and I will say something about the company who produced this robot, they knew exactly what they were doing. Not too tall, but tall enough to be taken seriously. A humanoid robot. Now here are the most well-known robots that are around that you can buy in a shop. Theoretically, if you have $20,000, you can go in a shop and buy a Pepper. By the way, the one I showed previously, Asimo, is another one, a big one. It's about $1 million, and it's in the experimental version. So that's not recommendable for the ordinary teaching and learning process. But these are affordable now, costs about 7,000 US dollars, and Pepper around 20,000 US dollars, depending on tax and the country where you buy these robots. They're produced by the Japanese company SoftBank. The software was written by a French institution called Aldebaran, and 2 years ago, SoftBank simply bought Aldebaran. SoftBank is the largest robot producer in the world. And now they have their center in Paris, in France. What can these robots do? Well, let's look at some features. Here are some general features. They can all speak. Now, this robot has one speech module implemented, namely American English. This is due to the fact that it is on loan. So CUHK hasn't bought this robot yet, so they have one speech module. If you buy the robot, you get a second one, which in your case would be Chinese. In our case, it's German. The robot can speak 21 languages, but you can only implement 2 at the same time. Well, then the robot can move. I don't want to move him really, but you see, if I press this button here, then the robot should turn around. Not this one, not the Hong Kong one, there we are. So the robot moves. I want him back in the original position. And in teaching and learning, the general idea is that they stand still. Okay? So the robot moves. The robot can also move his arms. We will see that in a second. The robot can recognize objects. We have 2 cameras here. The cameras, one above and one below the eyes. The robot has object recognizers and distance measures down here. These are lasers and sonar distance measures and a number of things to orient in the room. So whether it's that the robot knows where he is. The robot can show emotions. We will see that in a second. And the robot has a secondary sound channel, so the robot can play media. The robot has a tablet. This one can show things. And it is on the web, just like your smartphone. The robot is online at the moment. So theoretically, but we haven't implemented yet, this one on the Hong Kong robot, we can access Wikipedia like you do. Ask a question and the robot gives you the answer. So now then is a little bit special. Now is smaller, this one, 58 centimeters. Now has legs. Now can walk on these legs very slowly, about 1 meter per 5 minutes. So very slowly. And the activation of programs happens via spoken triggers. So you have to say something to Now, something like Hong Kong, and then the robot runs a program. Okay? And the primary role of Now, as we will see in a second, is that of a tool, not that of a partner in education. Whereas with this one here, with Pepper, it is all different. Pepper has the right size, movement, as you've just seen, on wheels. Pepper has this tablet, so basically it's 2 computers, the robot and the tablet. The tablet acts just like your smartphone. And then the activations can happen via spoken trigger or via the tablet, like you do on your smartphone. You click on an app and that's it. And the primary role, as you will see in a second, is that of a partner. And Pepper can show emotions. So I think you all agree that we saw sadness and happiness or fun. And of course, there's no limit to implement these emotions, since you have an unlimited movement of arms and ligaments. You can move each finger. There are motors in each finger. You have 3 motors, which can be addressed independently via programming. You have the face. Of course, there's no gestural, there are gestures are an option, but facial movements are impossible. So what the robot does, the robot uses colors in the eyes. So that's emotions. And now our idea is that we develop these customized robot apps which can be used in the classroom, which can do certain things which we want the robot to do, but we will not simply move a robot into the classroom and tell him, now go ahead and do whatever you want. No, we will very precisely define robot applications for the classroom. Okay, so much, first of all, for the robots themselves. And now let's look at robots in the classroom. Here you already see some settings in my classroom. My classroom is the inverted or flipped classroom, so I never teach in anything else. Whatever the number of students, between 20 students and 230, I always have the inverted classroom method. So nothing else. But we will see in a second what I mean. The first option of using a robot is using the robot as a tool. So we don't want to use it in class as our partner to do things for us. We want to use the robot as a tool, and excellent for this tool function are the now robots, the small ones. You see here, pupils at school, they use the robot in order to understand how the digital world operates. So these days we have demands on our school kids all over the world that they have to do more in terms of computer science, in terms of coding, and the robots as tools are brilliant because you can immediately see what you do, and I will show you something in a second. Now, here you see the second function, first of all, the partner function. So tool versus partner, completely different. Partner, then he is almost on level, on par with me in class. But the tool function does not play any role in class. Here is the tool function in one detail, so one example. We call this educational robotics, by the way. So when we use the robot as a tool. And this is what the students have to do. Some of you have seen this before. This is called block programming, and then you can support that by a programming language called Python. It depends on how deeply you want to go into the robot coding with your pupils, depending a little bit on age, on background knowledge, and so on. And well, this is what we do. We have created the so-called Roboticum, which is a 3-day course for pupils in my hometown, Marburg, in Germany, where week after week, classes between the age of 12 to 16 come for 3 days and learn how to operate a robot. And I can tell you their algorithmic thinking is changing dramatically during these 3 days. It's amazing how they change. Here's an example. Let me show it to you. It's in German, but we subtitled it. Can we hear that? So they programmed the robot so that the robot took this pen, then looked at the student, decided who he is. Now he looked at it, and then he said, "It's Paul, pick it up yourself." If another face was recognized, the robot would have said, "Here you have the pen." So this program requires an enormous amount of understanding of how digital elements work. So the now robots are pretty good. Here they are in picking up things, in moving things around, in even playing football, believe it or not. So this is a tool function, but that's not the one I want to mention today. We want to look at the partner function, but first of all, this is a project we're running. It's called RoboPrax, where we have this Roboticum in the center and a massive open online course for the pupils in advance so that they understand the basics. Then we go to the school. We have a room with 15 laptops and 4 robots. We educate the kids 3 days, and then the next week, the next class comes. And we evaluate that, of course, scientifically in adapting the programs for our target groups. Believe it or not, there's an enormous difference between girls and boys. And we have to create different target programs for them to come to grips. For example, when girls create dialogues with robots, they're much nicer and friendly as compared with boys. Boys like to use 4-letter words all the time. Okay, so this is our project, which is a project about educational robotics, robots as tools. But now as partners, where can we use them in class? This is our goal. First of all, and I want to talk about artificial intelligence as well. Remember, not just robots. Where do we use artificial intelligence? One option is we use software. Software that has this artificial intelligence that can help us in the learning process. Chatbots, you call these things, or softbots. Then we can, here is a chatbot. Perhaps you've seen that. ELIZA. That was the first chatbot around in the world in 1968, programmed by Joseph Weizenbaum. You remember the name I told you at lunch? Weizenbaum, a German computer scientist who had to emigrate to the United States during the Nazi time or shortly after. And he developed this ELIZA chatbot using Lisp, a programming language of the 1970s. And this chatbot answers any question you ask him. And if the chatbot doesn't know an answer, it creates one. Sometimes absolutely stupid. But the chatbot will never stop talking, and the chatbot will, for those who are familiar with computer science, will pass the Turing test. So, that's a chatbot. Then we could theoretically think about Alexa. Many of us have Alexa. I have an Alexa at home, and Alexa is pretty good, I must say. But do you want to be taught by a box? Our students said no. They cannot imagine a box standing here and giving advice. And also, I mean, you all possibly, after this session, and we invite you to do that, you probably want to have a selfie with him. Has anyone ever thought having a selfie with Alexa? No, you don't want to be a photo with this thing. Or Echo Dot, or whatever they're called. So you don't want that. Pedagogical agents is another possibility. These are avatars on the screen, personalized helpers on screen, with which you can interact. Basically, you do that in terms of written input, which is a little bit, boring, or it's too much effort. We don't want to type all the time. But pedagogical agents have been in use since the 1990s, especially in mechanics, in areas where we can't access the rooms for reasons of poisoning, etc. So these are typical artificial intelligence methods in teaching and learning. However, the prerequisite is your teaching and learning must be somehow digital, because you need data, you need a computer to do that. Now let's look at the robots as partners. The first partnership you see here, and these are not actual partnerships where the robot is partnered with me, and we will show you these things in a second. In-class assistance. The robot does things that I don't want to do, takes over the task, and gives me a lot of freedom to do what I want to do, what I prefer to do. Secondly, in-class advice for the students. So the robot could be some sort of info point for the students. The students have a question. Normally they take out their smartphone, but some questions can be so specific that you prepare specific databases, let's say for linguistic terminology. I'm a linguist, and we need very often to answer questions like, what is an allomorph? If you Google that, Wikipedia doesn't know it perfectly well. You could prepare a robot to answer all these very specific questions. Then we have the advice partner function, where the robot can function as a sort of advisor, and I will show you the student advisor app, where the robot, in our case, gives office hours. Believe it or not, office hours with a robot. You will see it. And finally, the robot as an examiner. Oral exams with a robot. Today we have thousands, if not 10,000s of students who do courses, online courses all over the world. Let's say they do a Python course with Coursera, an American platform, and you're a computer scientist. The student comes and tells you, well, do I really have to attend your Python class? I've done a course with Coursera. Then your question is, how can you show to me that you did that course? I would take the robot and ask him to do some short exam with the student, where the student can show his knowledge of Python, and that's it. If you have to do that with 100 students, you don't have the time. Could be an option. We're thinking about implementing these things also for students who forgot to deliver a particular task. We would then say, go next door, do the task with the robot, and off you go. Okay, these are partner functions. And now the question, where can we use them? Where, in what position of the teaching and learning process? Is it possible to use the robot in traditional lecturing? I'm not answering these questions now. Could we think about the robot to be our assistant in the homework phase? Think about it. Is it possible to have the robot during the online learning process? As I said, I'm not saying yes or no now. Could we think about the robot to have it as an assistant in class settings, in particular in class settings which are highly interactive, as you can see here, where students sit around the table? We saw some videos earlier on where exactly this situation was shown. Could it be possible to use the robot during mastery learning processes where students have to pass tests? Another question. Or is a robot a useful partner when it comes to support of any kind? Help, assistance, support. These are the possibilities, and not all of them are applicable. And in order to understand which ones are applicable, we have to look at teaching and learning in general. And what I mean is teaching and learning in the digital age. So let's look at this digital learning. This is classical teaching and learning. In class, content delivery, like I do now. So I'm a classical teacher at the moment, but I only give one lecture and not 15 on the trot. So you are my audience, I'm here, classical teaching. The second phase would then be the deepening phase, where you would have to do some homework. Of course, that's not today, not for you. So that's the two phases. Now, many people say, okay, we can digitize that. What would they do? All over the world, PowerPoint, data projector. That's what they normally do. Digitizing teaching and learning. Well, in the phase of deepening, they would say, okay, PDF. Turn everything into PDF and make it available to the students, homework, text to read, scripts, slides, everything into PDF. Some people even record videos here and make it available. This is no change of teaching. This is not teaching of the 21st century. It's teaching of the past, digitally corrected and cosmetically corrected, but nothing more. This is not the teaching we can do now, because we have far more possibilities. And the possibilities are these. First of all, the question is, can we use a robot in this setting? We could say, what many people say in the first place, we could use the robot as a lecturer. The robot replaces me and now stands here and lectures. Perhaps we should look at it and look at the robot as a lecturer. Your turn, Pepper.
Hey, I hope you are ready to learn something about morphological processes and word building. I will try to make it interesting. As you can see on my screen, there are two main types of processes: inflection and word formation. First, let's look at inflection. Take these two English sentences. This man is a doctor and these men are doctors. We must change.
I think we're all bored to death, aren't we? Could you imagine this going on for 30 minutes, for 2 minutes even? I can't. There is no chance that a robot can be used as a lecturer these days. The robot is not flexible enough. The robot can't react to the audience. So if anyone stands up and shows a reaction, the robot is helpless. The robot can only go on with his text and simply, well, sort of don't even elaborate on the text. Nothing. Predefined text, predefined role, that's it. So, as a lecturer, no chance. I hope you all agree. So the first fear can be wiped away. We will not be replaced by robots. That's the first question. Many people ask in the first place. But this robot definitely will not replace us. Too bad for the robot. So, and this is what we found. We made an experiment with exactly that. We had the following options. We had 4 groups. The first group had to listen to the robot where the robot didn't move. No movement, no tablet. The second group, tablet, information, but no movement. The third group, no tablet, but movement, full of animations. And the fourth group was what Pepper has just done, movement and tablet. And the result, in all cases, we had an exam afterwards, was equally bad. So we have evidence that this is not a function that the robot can take over. So in traditional teaching and learning, forget about robots. So the question, when you now ask Paul Lam, can we have the robot next week? Then he should ask you the first question, what sort of teaching and learning do you prefer? What is your strategy? What is your format? And if you say, I give a lecture and want the robot to take over 10 minutes, I would say his position, leave the robot where it belongs, namely at CLEAR. Okay, so, but what could we also do? We could perhaps use the robot as someone who asks questions in class. Shall we try that? You have the coactum pingo system earlier on. And now we will activate the robot. Now you can see the tablet content on the big screen. So one prerequisite for the use of the robot in class is that we make this screen available to all of you. Because otherwise, people in the back couldn't see anything. And it's no use if the robot does some work and the tablet is hidden to most of you. So we see the tablet here. And now for the teacher, it's absolutely simple. I'm using a system, not Kahoot, not Mentimeter, but I'm using a system called Pingo. Now I want to ask you a question. And if your smartphone doesn't respond, please swipe once, refresh the page, and then you can go ahead. And here is the question.
Please answer the survey. Reply within 45 seconds. Here is the survey. The time is set to 45 seconds. The time to vote has expired. Here are the results.
There are the results. We have to look at the second thing. And I'm quite happy that only 3 votes have been given for the robot as teachers. I told you in advance, so you should have learned that already. So where are the 3 votes? Anyway, what you saw here is a live voting system. The live voting system, which I would normally control with my laptop, can now be transferred to the robot. And you see, apart from 2 clicks, I didn't have to do anything. The robot did everything for me. The questions for this live voting system come from a database, which I can create as a lecturer on my desk. So that's already a big advantage for me. As a lecturer, as a person in class, I can now ask questions. In traditional teaching and learning scenarios, though, this is of course not a good idea because it takes away time you need in order to introduce the content. But if you are in a flipped classroom scenario, you have all the time in the world in the in-class meeting to ask questions, to do special tasks, and so on. So that's one application. Okay, a second application is the following, and this is what we did. Now, what can we do in this digital teaching and learning scenario? This is digital teaching and learning. The first phase has now become fully digital, content delivery via the internet. You saw that in these wonderful video series earlier on. And the in-class meeting is dedicated to deepening, to discussions, to all sorts of things. Now, as I said yesterday, this system doesn't work very well because you need to know a very important thing. Before you go to this in-class meeting, you have to understand, have your students gone through that phase and have they mastered the content? If you don't have any information about that, your system will not work very well. So we decided to introduce what we call mastery learning, an online phase in between, where students go through an online test where they show their knowledge about the content. And then I go into the in-class meeting and know 80%, that's in fact the average value, 80% of my students have passed the test, they understand what it's all about, now I can practice with them. So that's the model of teaching and learning. We call it the inverted classroom plus mastery or inverted classroom mastery model. And that's really the model that has been working for almost 10 years now at my university in my subject, with changes, of course, here and there. 10 years in the digital age, nothing will remain stable, but it works. Well, and now we can use robots maybe. Where? First of all, we have data now. Traditional teaching and learning has no data. Unless I ask my students to tell me, how long did it take you to read the article by Smith yesterday? How much time did you spend on listening to me in the in-class meeting? And then I write it down and collect data. But in the digital teaching and learning scenario, you get this data automatically. It's contained in the platform. So what data is it? First of all, we have this data here. The number of, let's say, clicks, the time spent in an online unit, the items visited in the online unit. We can use all that. Or we have here, in the test phase, we have test results. How well did students do a particular test? How often did they have to do the test before they passed it? And so on and so forth. Did they do the test at all? Today we call this big data, and what we do here is called learner analytics. So that's one option. The second option is the in-class option. We could use the robot in class as an assistant. And you see, this arrow is quite interesting. This opens a new option. It opens the option that the robot can use the data, the digital data, and then go into a conversation about the data with the student. This is the so-called, the first app we can have here in class is the Quizmaster app. An app where you first of all have to work on a particular topic in class, let's say 5 minutes, and then we will practice that with you later on. And then you are asked a question about it. The questions we ask the students come from our databases where we store our electronic exam questions. And students find that very helpful because they think, oh, this question the robot asks might reoccur in the real exam. Very attractive. They don't know that we have 5,000 questions, that the chances are very slim that the question turns up, but nevertheless, the hope is always there. So we need the Quizmaster app. Now we want to show that, and they have to activate it. Still, the tablet is still the loading controller. So we have to load the app. The apps. There we are. There we are. And I have to reload my screen again because I want you to see it. There it is. HEART is our project, Humanoid Emotional Assistant Robots in Teaching. That's the title of the project. And now again, we need the screen, the tablet. What you see here is also there. That's essential. And you see the technology I'm using here is tricky. It's a so-called screen sharing technology where I simulate a server on my laptop. And that connects with the internet and his tablet. This is again the illusion I have to take away that everything is simple. It's really complicated to do these things. And so now here you see quizzes, and I want to start, let's say, the exam preparation with my students. And here we are.
Start a manual quiz by clicking on or saying begin, or an automated quiz through begin auto.
So we can, I can't say the word begin now because then he will understand me. So we have two options. We can talk to the robot or we can operate the robot via these buttons, which is much more convenient to most teachers, the buttons and not talking to him. And we can do it manually or automatically. Okay, yes. So we can ask several questions on the trot. The robot will time these questions, the students will do their work, they can Google, they can do everything, and for each question the robot will give a certain amount of time, and I will go for the automatic option.
Consider the following question.
And now my position is this.
How many vowels does the word incomprehensible contain?
Okay,
You got 2 minutes.
So can I help you? Incomprehensible, how many vowels? Vowels. There's a time. So this is my position as a teacher now. I help my students. And I don't have to do anything there. The robot takes over. Now 5 questions of this type will come. And then the robot will present the solutions and we'll discuss the solutions. And the questions come from our exam databases. And they're chosen at random. So this is a good option for the students. And I will break it off. Now, of course, this question is, since we're linguists, you have to transfer this word into its phonetic code. And then you have to understand what a vowel is. If you Google that, no chance. And there you see these are competence questions. Competence questions for our final exams, which can be solved electronically, because you need a number. And I think the number is 5. Incomprehensible. 5. Bingo is 6. No, you will see the solution. Well, let's see. No, we're not in bingo now. Okay, let's see what the robot says. We're still 45 seconds. I could check it with you. In personal assistance, I would have said, think about the last syllable, because the last syllable doesn't contain a vowel. It's a so-called syllabic consonant. Aha, there we are.
30 seconds left.
And so the robot reminds us. We have some questions where we even have assistance. After 30 seconds or so, the robot says, think about the last syllable. Something like that. So all these are questions which we have in class. You see, I don't have to do anything. Normally, I'm not talking. This is today different. I just go through the rows and check my students. Can you do it? What do you have to do? And so on. And now...
The time is up. Relax a moment before the next question.
Oh, the next question. He wants to do the next question. So I say...
Let's go through the solutions.
There are the solutions.
Here is the solution to the displayed task.
Because you want to see them.
5. Let me explain this solution. Incomprehensible contains 5 vowels, 1 in each syllable, except the last one.
There you are.
I will continue after a short break.
No, we've had enough. So that is the Quizmaster app.
I will go to the home screen.
And that's it. So you can use that now, of course, in class meetings. However, you have to have the time. So it's something for digital teaching and learning, for the inverted classroom, nothing for the lecture hall where you lecture. No chance. Okay, let's return to our digital teaching and learning system. So here is the Quizmaster app. And then now I think one of our highlights is the next app, the so-called Student Advisor app. The Student Advisor app takes the data from that were generated digitally and it puts the robot in an office and the student can get advice from the robot about his or her performance. So we simulate that now. Now, how would you say can a student identify that it is Paul Smith in front of the robot? The robot can do face recognition. But face recognition is far too bad and too unstable and not 100% secure. Imagine Paul Smith stood here and the robot would recognize John Miller by
Please
mistake.
show me your QR code.
Oh, he's already there. And John Miller would operate with the data of Paul Smith. That would be a disaster. So we have to learn. He will. No, leave it as it is. So what we have decided to do is
I couldn't scan your QR code.
bit tricky.
May I try again?
Yes.
Okay, we
Students
will
have
try
their
this
private
again.
QR code.
Your QR code, please. Okay, I have your QR code. Processing the code.
It's processing. Now he's contacting the database in Marburg. It takes a little time. There we are.
Hello.
No, I don't show that.
This is the class Introduction to Linguistics for BA students of English, WT 2018.
Okay.
You have worked on most units. That is impressive. Take a look at my tablet to see the missing units.
So,
Why haven't you studied these units? Did you have technical difficulties? Comprehension problems? Problems with your time management? Or other reasons?
so I have to give you some explanation. What I loaded here were.
I will display a keyboard on my tablet. Then you can enter your reason.
I'm now in a dialogue with the robot. It's difficult to do this in class. The robot has loaded the real data of a real student. That's why I'm not showing it here. I'm violating data security now. The name of the student, so I cancel this. The name of the student is here. It's a person called Wiebke. And he said at the very beginning, when he identified Wiebke, he said, "You studied most of the units. That's very impressive." And then he said, "You didn't do 2 tests." And the 2 tests are here. You can see them here. One of the tests is phrase structure. One of the tests is the lexicon overview. The date of that situation was the 31st of January. The problem is, at the moment, we have vacation in Germany, so I can't load any student data. So we had to save the database for today, on the 31st of January. Meanwhile, Wiebke is ready. She passed everything and she is going on to the next term. Now, this sort of student advice, which is also protocolled in terms of an email, so the student will receive an email about what we're doing here. So the robot, I don't know where we are now. Technical difficulties. I don't know where we are because I talked so much.
I'll go back.
Okay. So now I can ask general information as well. When are the office hours? When are the office hours?
Look at my tablet screen for the information.
So office hours, you have a number of aspects where you as a teacher are fed up totally. So my example is always when 5 students come into your office and all 5 students ask the same question. When are the office hours? The first is nice, the second is okay, but the last one you would really give a kick somewhere and okay, I'm not continuing. So we put that to the robot. Office hours, exam dates, exam preparation advice, and so on and so forth. So you can see all sorts of things here. And the robot goes into a very complex dialogue with the student, generates a protocol, which is emailed to the student at the end. At the moment, my research assistant, he will be, it's now 11 o'clock in Germany, he will be very surprised to receive a control email at the moment. And then he knows we did something in Hong Kong. So this is really an application, the student advisor app, which will be used from April onwards when the new term starts. We will have 2 hours per week, office hours with a robot. And then students produce their QR code, which they can generate via our platform, and then they get advice. Okay, I think we can leave it here, this system. So now we have 2 elements which can be used, and now we are preparing the robot to show something which these 2 a little bit with my advice created during the past 2 days here in Hong Kong. I will continue, but they have to prepare the robot. That is why Kevin is running up and down here for the moment. So ignore him. Okay. So the benefits. Now, one thing, when we use robots in class, and that's highly important, don't do it if there's no benefit. If there's no benefit for the coach, forget it. If there's no benefit for the student, forget it. But if there's benefit for either of them, then you can try. The voting controller app had a high degree of benefit for me, but not for the students. But for me, it was just easier. So, after all, we humans are the coaches. Never forget that. We have everything under our control. The robot should not take away control from us. It's us who decide what we do in class. But we can gain time. We can gain time for more individual training. I sat next to you, the robot did his job. I gained 2 minutes. And if I ask 5 questions, I gain 10 minutes for individual coaching. That's rewarding for me. Rewarding. We can didactically simplify. That's something I did not show. The robots are very naive, aren't they? It looks like a child, very naive. So the robot can ask questions which humans should never ask. So if I told you, for example, you have a wonderful blouse, I'm close to becoming a member of the platform Me Too. But if the robot does it, no problem. You look very beautiful. If the robot says that, fine. If I do it, oh, it's a bit strange, isn't it? So the robot is a naive partner, and you can use that naive partnership in giving the robot questions the robot has to ask, which colleagues would not ask. For example, I have one situation where the robot asked me the question, Jürgen, do you speak Turkish? I wanted that question to be asked. Students wouldn't ask me the question, colleagues wouldn't, and so I couldn't ask the question myself. Once the robot asked the question, I could explain to the audience, as a linguist, you don't have to speak languages, you have to be able to analyze them. And that's exactly what I wanted to tell the audience with this naive question. So naive simplification, didactic simplification, naive partnership, we call that. And finally, individualization. I showed it to you. I sat next to one student and talked to her, then I talked to you, and so on and so forth. So what do they look like, these applications? This is once more, before we then come to the CUHK application. Here is the first app. You saw that, the Quizmaster app. The robot asks questions, has time under control, presents a solution. I don't have to say anything about it anymore. The second app is the Quizmaster app. Once more, identification via the QR code, and then the robot enters into a very complex dialogue about learner data. Number 3, we use the robot in class. That's an option which is relatively rewarding. In small classes, I don't know the situation at CUHK, if you have a small seminar, let's say 20 students, and you see them for the first time, this situation occurs quite often, and you don't know the names of the students. They come to you, first session, opening session. We had the idea, and it worked relatively well. The robot introduces the students. The robot says, this is Carmen Lau. Carmen, what makes you come into my seminar? And then she would say, Pepper, I came here before because of the following reasons. Here we have an example, I think. Say something about the students.
Okay, let's contact them. Melanie, what made you come here?
Marilyn, why did you come here?
I'm here because I lived 2 years in the States
and so on. So the robot introduced the students at random, and then the students were shocked at that moment. They had to say something about themselves. Each had to say at least a sentence. And I, as the coach, I could draw a plan where the students are. And then immediately I knew the names. So that's an opening app which can be used once. And it can be used, we found out, up to 20 students, not more. That's a good idea. Here is a naive partnership app where I asked this question about Turkish. where the robot was even in a video with me. I produced a video about what is it phonological conditioning, which is on YouTube. You can look at the video yourselves, and where the robot was in a dialogue with me. Okay, and here are the benefits. Now, the benefits and the usability is, of course, a different question. Usability at the moment, the red cross says no, the robot's arm eye says yes. You see, it's all yes and no. It's so difficult to get the robot running, to have it here in class, to prepare the app, which we will see in a second. 2 students have to come here, roll the robot, and so on. The whole logistic problem is enormous at the moment. But gain of time, I think I could show you that in the student advisor app, of course. The time gain for me is fantastic. I do not have to talk about these silly things anymore. The robot does it for me. And in the Quizmaster app, I gain time in advising students enormously. The Master of Ceremonies app, that was where the robot introduces students. Well, time gain, not really, because you have to be aware, you have to do something. And the naive partnership is invalid here. The second one, didactic simplification. Well, in the student advisor app, there's no didactics involved. In the Quizmaster app, didactic simplification, no. But in the Master of Ceremonies app, you can simplify things. And in the naive partnership, even more so. Finally, individualization. Well, again, here, the first 2 apps, individualization, I showed it to you. In the partnership and in the Master of Ceremonies app, you don't have any chance to individualize. So this is the current state of affairs. Now, what does the future hold? And you will see the future in a second. The idea is that we will now, from now on, not develop these simple apps, which I've shown you. The apps themselves are not simple, they're highly complicated. But what you see is relatively simple. We will generate what I first of all called, and I will have to talk to the clear people, we want to enter into a very solid partnership to develop these things between Marburg and Hong Kong. And we will think about a name here. I call it classroom packages. So that's the new sort of things we want to do. The package takes over, or the robot will take over, let's say, 30 minutes or even more. The package contains a number of in-class actions. For example, the introduction to a topic, then some questions to start off with. How well are you pre-prepared? Then a task which you have to do, maybe a second task. Then a control question about the task. And then finally, maybe an evaluation where students can deliver their opinion how well they did it and how they found the whole things, whether they accepted it or not. So that's the real task which we do in inverted classroom scenarios as humans. Now we combine them to robot apps. It's a list of robot apps. In our case, the Master of Ceremonies app, introducing a topic. The live voting thing, you remember, Bingo. The live voting app. Then the presenter app, which is bad at the moment. You saw that at the very beginning. The robot presents something, but we don't want to listen to it. Then the Quizmaster app, control questions about the topic, and finally an evaluation, which we haven't programmed yet. So this could then result in a sort of cumulative app template. A template which every one of us has on their desk. You're sitting in front of a screen, you have the app template. And then you fill that template with data, with your tasks. From this data, you generate your personal robot app. So one step could be you, as a coach, you fill the template with your data before your in-class meeting. Let's say an hour beforehand. You're sitting on in front of your private laptop in your office, generate the data, type it into a front end, and upload it to the robot. In class, the robot takes over. You possibly say something like, hello, or you touch him somewhere, and then the robot starts doing the work. Fully automatically. You don't have to care. And your position at the very beginning is there, or there, or there. You just start the robot. Well, and we want to show it to you. They have created, I must say, I just gave a little bit of advice. We have created an app which we based on your voting system, uReply. We called it uReply Plus. And we will simulate now, we have measured the time, 10 minutes or so, of such an app, and you have to do the work, real work. So let's start. Okay.
Let's start now. Thank you, Professor Hanke. Hello, everyone. I am Pepper. It is nice to meet you.
What has happened to his voice?
Following 20 minutes.
Perhaps you start again.
Demonstrate the basic principles of robots assistance.
There's something wrong with the speech recognition and speech synthesis device. It's a pity. Yeah. Let's start again.
Then, in the session number, you may leave the students and I get ready.
What they have programmed at the moment is a screen where you, as a teacher, have to scan this QR code, and then the robot knows that you are the right person to interact. That you are the right person to interact with the robot. The idea is that we dispense with that in future, that you identify beforehand from your desk. So let's say 10 minutes before you're in class meeting, you press return from your desk, and then the robot knows you're coming. Which means, of course, you don't have to stumble, you don't have to take the wrong way, you have to go straight into your classroom.
Let's get started with the first question.
Yeah, okay.
Here it is. You can view the question on the screen outside or on your mobile devices. I want to know what your options are.
So now you have to scan this QR code. We will start with a question. And you should then have this serial number on your smartphone, and then you will see the question.
Good work. I have received answers from all. Great. I have received lots of replies from all of you. Let us check out the statistic now.
So now this is the first phase of the in-class meeting. You have given an answer. You see, one problem is that I don't see what is E. What was E? I have my smartphone not installed. I see. Yeah, E. So you think 25 or later? I would agree. I would perhaps say it's 2024 because there will be new German university opened in 2025, and they will start implementing robots a little bit earlier. But I think it's reasonable. So this is the first step of your in-class meeting. You ask a question and you comment, of course, the solutions. You can say something about the solution, which is a didactic principle, which is always good. So that you can say 2021 is possibly too early because technology will not be ready, and so on. So that's the first task. Now the robot goes on, automatically, ideally.
Here is the second question. Please tell me about your views. Wonderful. I have heard many different voices from you. Let's see how those responses are.
So that's why the teacher has to be here and not on the stage. I like your answers. The same question in Germany would have shown completely different answers. Fear, anger, afraid. This is why it's so important to work out the cultural differences between, let's say, Hong Kong and the city of Marburg, and German teachers and Chinese teachers. So that's the second question. Now we have given you some questions. We have an idea, and now the robot will continue. As I said, normally automatically.
Now, I will give you a simple task. You can now go online to find for any information about the use of humanoid robot in China. You would have about 5 minutes to look for those relevant articles.
Okay. Now, normally on the robot, you will see this clock here, which Kevin is presenting. You have 5 minutes time to do the job. And I, as your coach, will assist you. So It's up to you. Do some work. Try and answer that question. This is now on your smartphone. You have to log in via the screen of the robot. So that's going to be done now. But you can still try and solve the task online with humanoid robots in China. Time is up. So, and now this is a typical scenario of an inverted classroom. You have to do some work.
I hope you find information about Yin if you work well. You can find a better feature that is better than mine. Please list at least one functions that Yin has which I don't. All of you have made a good response. Now, let's check out the answers together.
This is one of the key answers. It's a service robot. Yin is a service robot. It's not a social robot like Pepper. I was talking about humanoid robots first of all. Now we can classify humanoid robots into several types. She's Chinese and you are Japanese. Okay. All right. Doesn't have to go to the toilet. But really, this is the answer. It's a service robot, a robot that can carry things, that can bring things from point A to B. That's Yin. It's a prototype at the moment. So China is producing a number of prototypes, but I'm sure that in a few years we won't talk about Pepper anymore, but about our Ovo robots from Jiangsu. Hello. Yes. So that's the end of now. I don't know how long it lasted, 10, 15 minutes. And then automatically the robot would say, that's it.
That's all of my part. Now, I will hand over to my dear colleague, the coach.
So he hands over to me again, and now I can do something else. So this is the idea of having these classroom apps to have a complex collection of tasks that they carry out. They do it, we don't have to care. Normally we wouldn't have Oscar here who presses the buttons. So you learned a lot as well. You know what has to be automatized on the robot, and they will do so. We will do so together as a joint team, Marburg and Hong Kong. And we will develop more and more of these apps. And the final solution will be that you as a teacher, you just have to upload your stuff, then the robot will do the job. Of course, you have to have a team of roadies who carry the robot into class. So logistics is still the problem. And if you are willing to solve these logistics, well, then it may work. But if you want everything to happen automatically, then you have to wait until, what did we say, 2025 or longer. So let me summarize. So where are the final? Yes. The final, my final slides are now have been converted to the robot. This is also, you can use your PowerPoint presentation on the robot. That's another option. So my laptop is now no longer valid. It's the robot. So we switched roles in the meantime, but I only have two slides, and this is basically the last slide. You can now see what the use of robots as a summary is all about. We have big data, which we can analyze. Customized advice, that's the student advisor app. And in class, we use the robot to have customized robot apps. And the uReply Plus was just an early example. I think it must have been the first example in the world, as far as I know, the robot assistance community all over the world. And it didn't work very well, but it shows you the basic steps. And we will, as Paul told me, how many months did you give us? 6? Well, if it could be a matter of a few days. No, it'll take some time to customize these things, to develop a front end where you type in the information, and it's no effort for the teacher then to upload the information to the system. Students should have easy access in class to contact the robot, and then we have these customized apps which we can use in class. So that's it. What does the robot? Oh, you go on there. The next and final slide is this one. It is a video, but I don't want to play a video in class. If you're interested, then copy this thing here. It's a video produced by Deutsche Welle. It's in English about one day in the life of a humanoid robot at my university. So they followed me one day, starting at 7 o'clock in the morning, leaving at 6 o'clock in the evening. And it's a movie about the use of robot in class. And students were asked how they find the role of the robot, how they evaluated everything. The whole video is 12 minutes. I don't want you to watch it here now. So I just wanted to advertise a little bit. And this is the link. Is to say thank you for your attention. I hope we could give you some ideas about the use of robots. It's in its infancy at the moment. So, but we are the first to do it, to really do it. If you don't do it, others will do it. So that's why we think it's a good idea not only to do it, but also to cooperate, to gather new ideas. And I think here the cooperation between China and Europe will be very useful in order to develop things they do not develop in the United States. Okay, so thank you very much for your attention.